2.4 Sketching Graphs of Rational Functions, Part 1. Okay, so we want to be able to sketch these graphs without having to rely on graphing technology and to do minimal, if not no, table of values for some of them. So first things first, I couldn't do it. I had to say it. Okay, we're going to I want you to pause the video and I want you to factor the top. So you should have gotten x minus 4 and x minus 1. And on the bottom I have 1 minus x, so I'm going to divide out a negative 1 to make it x minus 1. There we go. Okay, let's check for our asymptotes first. So f of x is greater than g of x, which means I have an oblique asymptote. Good to know. All right, we also are going to cancel. So we cancel, and which means we have a hole. And the hole is at x equals 1. Our simplified equation is going to be x minus 4 over negative 1, so negative x minus 4, which is the same as negative x plus 4. So we're going to substitute in that negative 1, or positive 1, to find that our hole is at 1 and 3. So 1 and 3. We have no vertical asymptotes. So let's graph this, and I'll show you how to graph it. Okay, so just with this oblique asymptote, because our equation is left with just a line, the asymptote is the line, so we don't actually have to worry about the oblique asymptote for this one because it's just going to follow the line, so we don't need to do that work. But what we're going to do is we're going to graph this line as if it was a normal line. So we're going to go up to 4 and have a y-intercept and then have a slope of down 1 over 1. So it'll go down like this. And the only thing you have to keep in mind is that at 1 and 3 you have a hole. So make sure you just draw a circle there for the hole. And keep sketching, and then draw your line in. So it should look like that. So that's all you have to do. That's the whole sketch. So linear ones are obviously the easiest. They're wonderful. So if you're left with the line at the end, just graph the line. All right, example 2. Start by simplifying your equations. We have negative 2x squared, and on the bottom we can factor it to be x plus 5, x subtract 5. And I can see that f of x is equal to g of x, which means I'm going to have a horizontal asymptote, and the asymptote is going to be at a ratio of the leading coefficients. So my leading coefficients are negative 2 and 1, so at negative 2 over 1, or just negative 2. We have no holes because we can't cancel anything. We have a vertical asymptote at x equals negative 5 as well as at x equals 5. So let's sketch those in. So we'll put in our vertical asymptotes at 5 and negative 5. We also have a y at negative 2. Okay, to graph from here, the first thing that you're going to know is that whatever makes the top 0 is going to be an x-intercept. So anything you have remaining on the top that makes it 0 is going to make your x-intercepts. So negative 2x squared is going to equal 0, so x would equal 0. So I'm going to have an x-intercept right here. Oh, also, I just realized we didn't do domain and range for the last one. So let's go back to that. The domain for this is x cannot equal 1. Sorry that I'm jumping all over the place. And the range for this is y cannot equal 3. Okay, back to this one. I only noticed because I know we're going to have to do the domain and range for this one. What you want to do, well, I can take a guess of what it's going to look like in here. It's probably going to go like this and hug the axes. And I know it's going to do that because it's not going to go down and then stop. That makes no sense. But what you can do to test this is to check your behavior around the intercepts. So we're going to make a quick table of values. And what we're going to do is we're going to plug in a point just outside of this asymptote, so negative 5.01, and then something that's right here on this side, so 4.99 negative. And then we'll do the same thing for the other one, so positive 4.99 and positive 5.01. And what that will do is it will show you the behavior as it's getting close to that asymptote. So I want you to pause the video and I want you to plug these into the equations. So what you should have got is negative 501.5, 498.5, 498.5, and negative 501.5. So what that means is, as it's approaching this asymptote from this side, it's getting really little, so it's going to go like this. As it's approaching this asymptote from this side, it gets really big, which is what we have drawn. Same with this side. It's approaching the asymptote, it gets really big. I should have drawn this in red. And as it approaches the asymptote from the other side over here, it gets really small, so it looks like this. So I know I just drew a whole bunch of lines all over that graph, but what you should have graphed is just the red and the gray. Oh my gosh, 1 second. Okay, it should look like that. So that would be your graph. So our domain is it cannot equal 5 and negative 5 for all the real numbers. Oh, I rounded around. You know what goes there. And the range, so we can have it either be less than negative 2 or it can be greater than 0. There's our domain and range. And that is how you graph two types of rational functions. The next lesson we'll do another couple types. Bye!